When I implemented a circular buffer for the first module of this course, I avoided using a Q of t because we hadn't talked about generics yet, we hadn't talked about generic collections, so instead I implemented something that had a start pointer and an end pointer. Those were really just indexes into an array, a fixed size array of items. And all of this logic in here was really about manipulating those pointers so we know where to write and where to read and when to wrap around when we're overwriting something. But now that we know how easy it is to implement buffer using a first in, first out data structure like the queue, it would make sense to revisit circular buffer and see if we could do the same thing, or even if we could just inherit from buffer of t. Can I do that with generics? Absolutely. The important part here is that I want a circular buffer of t, so of double or of string, and I want the class that I derive from to have that same generic argument. I also want buffer to be a buffer of double if my circular buffer is of double. And that just means that these type names have to match. So if this is called, for some reason, z, well then I would have a compiler error, because that t that will be used to instantiate circular buffer is also going to be used to instantiate my base class, that buffer. So I need to have a t here, or rename everything to z, but t is much more conventional. And now I can have a circular buffer that derives from buffer of t, that can take advantage of some of the features that are already in here, but I will need to tweak some things. When someone writes into the buffer, we need to throw away items if we've exceeded the capacity. So let me set up buffer of t to function better as a base class. I'll make the queue protected so that it can be accessed. And then let's make the members virtual so that anyone who derives from this can tweak the behavior slightly. We'll have a virtual write method, and we'll have a virtual read method. And now I should be able to go into circular buffer and pretty much just wipe out my existing implementation. And instead we'll start this over from scratch. So the circular buffer is really just a special case of the buffer. It has a fixed size capacity. So I will probably need a constructor that will allow someone to specify the capacity, perhaps provide a default value if they don't. So the default capacity is 10. And then I will save that into a private field that's a member of this circular buffer class. So underscore capacity equals capacity. And then I will override the write method, and I'll let the base class write a value into the queue, and then just do a little post-processing to see if we've exceeded our capacity. So if queue count is greater than our capacity, that's when we want to throw away an item. How can I throw away an item? Just dequeue something. That will dequeue the oldest item in the list, and I don't need to inspect it, I don't need to return it, I just need to throw it away. And now if I do a build, looks like we're home free, except, yes, we should get an error because there are a couple unit tests out there that would like circular buffer to have an isFull property. And here comes a bit of a design decision. Should all buffers have an isFull property? Is this a property that I should make a member of the iBuffer interface so that everyone has to implement it? And there's some arguments for doing that. There's also some arguments for not doing that. I would say don't do that. Because really, the other buffer, it never is full. IsFull would always return false. We might run out of memory on the machine, but the buffer is never full. It's always trying to resize itself to fit more items inside. So to fix this compiler error, I'll allow circular buffer to have an isFull method, or a property, but I'm not going to make that a part of the interface definition. So when we want to find out if this is full, I'll just return queue.count equals capacity. And now I should be able to do a build, and we build successfully, and now I can go to the Test Explorer and see that all my tests still pass, which is good news. And now we can see that we can use generic type parameters with classes, we can use generic type parameters during inheritance, and we can also use generic type parameters with interfaces. So let's continue to explore the interface route because there's a number of interesting generic interfaces that are available in the .NET framework.